Hello and welcome to this pre-recorded event for the GCSE Design Technology Resistant Materials, Controlled Assessment Marking and Internal Standardisation Training. To help you get the most out of this feedback, you may want to have the following documents handy, as we will refer to them during the session. The most relevant one for today is the Candidate Mark Record Booklet, referred to as CMRB from now onwards. Please note the final point about assessing secure materials on the website and how your exams officer will be able to give you permission to use these documents. Our aims and objectives for this session are that you develop a sound understanding of the controlled assessment requirements, understand what the process of moderation is and your role as a centre to ensure it runs smoothly. We will look at some examples of student work and discuss the correct mark band level for each item you see. Please note that training materials cannot be specific with reference to individual marks gained, but will guide you to which level mark band is most appropriate. Low, medium or high mark bands will be referred to when we look at specific work. I hope that many of you have made good use of the reference materials contained on the website for resistant materials. The link here will take you to the main page for this subject. This slide also reminds you that the course is now linear and that the breakdown remains at 60% controlled assessment and 40% exam. On this slide is a 10-minute podcast that will help support you with the controlled assessment requirements for your centre. Here, I want to remind you that the controlled assessment for GCSE can be delivered in any of the following three ways. The traditional and most popular combined route of design and make the same product, or design one product but then make a different but linked product, or design and make separate products. Model 1. The traditional or combined design and make the same product. This should be very familiar to centres as it has been the norm for many years. I would expect that Year 10 or the first year of the course is used to develop basic skills in students, leading to tasks that develop investigation skills, product analysis, and model making, with designing and making at the heart of the practical experiences. These tasks will prepare students for their controlled assessment task, which will take place during Year 11 or their final year. Theory work for the exam would of course also need to be taught alongside practical activities. Models 2 and 3, where students would design one product and make another. This could be really helpful if centres wanted to design objects for competitions or wider community spaces. Whilst it may be possible to make a youth shelter for the local park, for example, it also would be outside of the remit of this specification to expect one student to do this well in the time they have available. However, designing one, ending with the final drawing, then making another product that the centre has provided the drawings and specification for, would be fine. The only problem would be to ensure that the new product would be challenging enough for Key Stage 4 students in order to access all the marks available for making. Centres should note that these models can be adapted to individual students and do not require the entire cohort to complete the same delivery model in order to access the marks available. I have seen it used well where a student has become disaffected by their original product and doesn't want to go on to make it, so the centre decided to change the product and re-energise the student. This method seems to work well for many centres, and it is growing in popularity. After all, who has space in their workshops to store 3 skateboard ramps whilst they are being made? However, students could design one without concerns for its physical realization. This slide comes from our website where a number of template sheets exist. For me, this is the most important sheet to use. It not only tells the moderator which of the 5 task areas is being used, but also has space for the design brief to be written. No marks are awarded for a student writing a brief. Assessment begins when they analyse it. Here is a screenshot of where to find the templates previously mentioned, and the live controlled assessment tasks are also contained here. Looking at the tasks, you can see just a few examples of what you could do with a student's work. They are reviewed every 2 years, but have been refined over many years and seldom change, as we feel that any projects centres wish to complete with students will fit under these headings as they are very broad. We shall look at the process of moderation now. Firstly, centres must mark the work of their students using the criteria found in both the specification and the CMRB. When doing so, start by looking at which is the best fit statement for the work you are assessing. Have all the criteria been met? Are some missing? Has it been well done? Getting the right box is so important. We want all our students to do well, but you are assessing your centre's work against national standards. Taking into account the evidence presented, you must decide what the most appropriate mark to award the student is. Having assessed the entire project, carefully add up the marks for both the design section and the making section to give a score out of 100. Have your total checked carefully by a colleague. It is at this stage that many centres trip up with admin issues. If the score found by the moderator does not match the true score, only the centre can fix this via their exams officer and Pearson directly. The next step is to carefully transfer the score to the optems sheet, which is sent from the exam board a few weeks prior to the submission date, or you may use the EDI method via your exams officer. The last step is to prepare your parcel to send to your appointed moderator at the address shown on the optems before the 15th of May. A helpful document exists on the website to guide you through this process stage by stage, including instructions on how to submit work if it is produced in an electronic or disk-based medium rather than a paper-based format. The triple sheet carbon copy optems form will look like this. The top copy is white. You should send this to Pearson. The yellow copy you should send with the work to the moderator. The green copy you should retain in your centre for your records. In this example, I asked the question what to send to the moderator. It should be all the work indicated by an asterisk next to the candidate number, plus the top and lowest scoring candidates if they were not included in the asterisked sample. So, in this case, the work of candidate 8043 should be sent as it was the top score, and 8034 as it was the lowest score. If any student randomly picked with an asterisk next to their name was withdrawn, then send another candidate to replace them. Try and ensure a good range of marks is seen if you have the choice. As this system is random, it does not know which teacher marked which project, or if they are boys or girls, etc. So, try and get the balance right. 9 times out of 10, you don't have a choice. Just send the asterisked selection and the top and the lowest. A good CMRB sent with each student's work helps moderators understand why centres have awarded marks to students. Text could be highlighted to show which criteria have been met, and notes by the teacher help explain where the work is to be found. as in the example shown on this slide. For example, research could be at the start of the project, but could also appear as part of development if a student looked at different finishes for their product or looked at fittings to use when considering how a door might be attached. Unless informed by teacher annotation, a moderator would only look for research at the start of the project and wonder why such a high mark was awarded with very little evidence present in the sequenced portfolio. A blank CMRB with just numbers is very much up for interpretation. We want to agree your marking. Having discussed the process, now let's look at some student work for each assessment criterion. This is where you will need to reference your assessment criteria found in the CMRB, or specification if you have one handy. Analysis. This is too brief and would score in the lower mark band. The centre bubble is too prescriptive and includes points of specification rather than analysing the brief. The surrounding words are generic, undetailed, and are simply labels without any development. Analysis should be based on questioning what needs to be found out about the problem in hand and should guide research. A template can look great, but this doesn't help the student get out of the lower mark band again. About 25% of the page is centre-produced and is restricting student responses. Remember, spellings are not assessed until testing and evaluating, so should be ignored. The comments are too brief here. Research. This shows a detailed product investigation with conclusions and good comments made by the student. The same student produces some good thoughts on a product deconstruction, looking at how it could have been made to help their ideas develop. Finally, the same student looks at the environment where the product will be used and draws conclusions. These sheets are just a sample from one student's work. There was more to see. This scores in the high mark band. Beware the inclusion of worthless questionnaires that add little to the project. What colour? What age are you? What gender? These do not help the student find out things about the product they want to make. Padding should also be avoided. The textbook does not need to be copied out endlessly. What students are trying to find out about their product is a much better approach to take. When researching materials, it is more relevant to wait until the design development section, where design decisions regarding required material properties have been made and any research can be focused, relevant and succinct. Generic, irrelevant materials research should be avoided. Specification. Statements are vague and lack specific, measurable content. There is a very basic sustainability comment, and some comments could have been justified better to take it to a higher level. Specification statements should be technical, measurable, and justified where possible. Most technical statements occur under performance requirements and user requirements, so these subsections should be well considered. Unfortunately, neither of these important areas is mentioned in this example. This work would score in the low to middle mark band. This is one of two sheets produced, but it does show how the product will be tested at the end to see if the specification points have been met. Work like this would be in the higher mark band. The same student has continued the first sheet to produce this more wordy specification document. Ideas. A great use of space here. Note that they have done 19 different ideas, which is about 15 too many. Good points include the cameo sketches and notes about materials and possible construction methods. When other sheets are taken into account, this is a high mark band student's work. Review. Without user group feedback, even good-looking work like this will be in the lower mark band. Marks out of 10 do not allow discussion to justify why one design idea is a better match for the specification than another. Development. Here, a medium mark band student's work has been shown, with good reasoning why a model has been made of their intended product and what they have learnt from this. This section should show a developed idea, not a repeat from the initial ideas section. The product must be refined, changed, tweaked to show good development detail to achieve high marks. User group feedback must be included. Final design. This often becomes mixed up with the development section. They are separate and use different skills. Here, SketchUp has been used, but without dimensions and a cutting list. A third person would not be able to make this product. More construction detail is needed to allow third-party manufacture. Still not shown is the cutting list, but now the student has indicated dimensions. Even though technical drawing skills are not perfect, the student has achieved well enough to access the high mark band. Production plan. Various ways of planning can be used. A Gantt chart, as shown here, is fine, but it must include quality control. This does not, and there are no details of how processes would be carried out or what equipment would be used. This simplistic example of planning would score in the low mark band. This example shows a better plan with more detail of processes. Statements made under quality control are advice for manufacture rather than QC checks. QC should describe what the check is, how it will be carried out, and what equipment will be used. This evidence would score in the medium mark band. Quality of manufacture. It is essential that the centre provides proof of how candidates made their product, as we, as moderators, are not in the room, and sometimes the level of skills used is not obvious from looking at a finished product in a photograph. Here, the witness statement on the CMRB is also used to see what tools and equipment a student has used. Testing and evaluation. QWC is assessed here, so a wordy document for the evaluation is good. What this section should be detailing is the final product and how it performed against the specifications and how good an end product it really is. Here, photographic evidence of tests is presented. Tests are described and include user group comments. Testing should always be carried out against measurable points of specification to check a product's fitness for purpose and overall success. The evidence shown here would achieve marks in the high band.